Hello everyone, welcome to my channel. So as we are discussing about the reagent chemistry, basically the reducing agent, the chemistry of lithium aluminum hydride. So in this particular video, we are going to learn the mechanism of different function functionability by lithium aluminum hydride. So in the first example, you can see here, if you take acid compound, when this particular acid compound reacts with lithium aluminum hydride, what happened? So that anionic part of this lithium aluminum hydride, it provides one equivalent of H minus ion, and it will attack over here in this particular electrophilic carbon, and ultimately in the first step it provides this kind of tetrahedral intermediate. Now further, followed by the elimination of this particular group, and ultimately it provides the corresponding aldehyde product, as you can see. Now further, this aldehyde product further reacts with this particular compound, and ultimately the result is, the final product is the corresponding alcohol. So therefore, if you take any acid compound and if you try to react with lithium aluminum hydride, obviously you have to use here either diethyl ether, low temperature, that is very important, low temperature. So therefore in the first step we will be getting the corresponding aldehyde product, and further this aldehyde product is also further reacts with this particular substrate, this particular compound, and ultimately as a result it provides the corresponding alcohol. Now if you take ester compound, so this is the general form or general structure of ester. So if you treat this ester in presence of lithium aluminum hydride, what will be the results? So in the mechanism you can see here, so this anionic part of this lithium aluminum hydride, so it provides the hydride, and that hydride it will attack over here, that H minus it will attack over here, and finally it provides this kind of intermediate, you can see, and as a result initial step it provides the aldehyde along with this byproduct. Now this aldehyde further reacts with this trihydride aluminum, and ultimately it provides this kind of tetrahedral intermediate, and followed by the acidic workup it will provide the alcohol product. So together we can say that if you take acid or ester compound and if you treat these two compound in presence of lithium aluminum hydride, it provides ultimately, finally, or you can say finally, alcohol product. So what about the acidic chloride compound and amide compound? So let us discuss over here. You can see, so if you take any acidic chloride, so if you treat with this acid chloride compound in presence of lithium aluminum hydride, so what happened? Initially it will provide the corresponding aldehyde product, and that aldehyde product further reacted with this trihydride aluminum, and ultimately acidic workup it provides alcohol product. So similarly you can see here, if you take any amide compound, that is a substituted amide compound, you can see that again it will provide the corresponding substituted amine product. So this is the intermediate, as you can see. So therefore, why we are not getting the alcohol product here? Because you can see that substituted amine, that particular group is not at all a good leaving group. That is why we are getting the substituted amine product. So let us take some classic example. Now if you take this kind of epoxide compound, you can see that this kind of epoxide compound, okay. So what happen if you treat this epoxide compound in presence of lithium aluminum hydride? What will be the product? I can see that hydride ion attacks epoxide by SN2 mode, and if the epoxide is unsymmetrical, it attacks to the less substituted carbon from the less hinder side. So therefore you can see in this particular cyclohexane based epoxide, you can see this is unsymmetrical epoxide where one methyl group is directly present in this carbon center while other carbon center remain vacant. So therefore that hydride attack, it will only possible through this particular site. So therefore ultimately we are getting this compound as a major product. Now if you take a symmetrical epoxide, you can see here this is 1,2 dimethyl, cyclohexane based epoxide. You can see that when this particular epoxide reacts with lithium aluminum hydride, so ultimately it provides this compound. Okay, so thank you very much.